Hello, today we're gonna demonstrate the performance of our Lightnovo miniRaman Microscope. And we are with James, Managing Director of Lightnovo UK,
Hello there.
and Oleksii, our CEO.
Hello, and of course, as usual, Yaroslav,
Hello.
Head of Customer Support, who will do filming, and as three Raman experts, we will discuss the results of the demonstration for the operation of this beautiful system. Let's take a bit more closer look on it. So it's a very small confocal research grade Raman microscope, and right now we're gonna demonstrate that it's really research grade. So basically we will try to show you lateral and axial resolution. What do we have here? 100x microscope objective with numerical aperture 0.9, samples. It's a mixture of PMMA and polystyrene beads, average diameter around 1 micron, and very accurate XYZ mapping stage. How accurate you will see very soon as a result of mapping. I close the cover. Microscope equipped with a Hall sensor, so basically it's class 1 laser safety system, which means we don't really need the safety goggles for operation. And James, let's show on the screen what's gonna happen right now. It's connected to your laptop through USB-C.
Yeah, exactly.
And what do we see on the screen?
So on the screen we have our visual microscopy system, so we're able to see the beads. At the moment I've got my step set to 1 micron, so let's get these into focus.
Okay. Oh, that looks great.
That looks very nice. So you can obviously use this to manipulate and move around your sample,
Okay.
but we also have our panorama viewer.
Okay.
So we're able to, using this tool, we can just take an image of an area,
Yeah.
just give it a moment, and boom, there we go.
That was really
It's
fast.
very fast system. And with this, we can, if let's turn the laser on, so we've got the light.
Oh, I see a little dot just in the center of the image.
Exactly, and as you can see, it corresponds to this little green dot here. So let's go and look at some polystyrene, let's say.
It matches where you click. We see great Raman spectrum, and it's precisely where you clicked.
Exactly. And
Can you demonstrate that it's super accurate? Select a little area of. Wow, really it goes to that bead.
Yep,
That's
straight to that
great.
bead, exactly where I want it.
Shall we do some mapping?
I think we definitely should do some mapping. So let's, using this tool in the panorama, I can have a look at these two beads.
Okay.
Send this over. Now these settings have been sent over to the Raman mapping settings, which
Okay.
are all up here.
Number of counts may be increased to 21 over 21, I guess,
Yeah, I
because we need better resolution now.
Yeah.
This is 150 nanometers step size now.
Exactly. So we have our laser selected, and so now all we have to do is press start.
Okay.
And we can return here, and we can see that the system is working away.
I see laser dot is moving, or basically sample is moving, and laser dot is following that.
Yeah. As you can see, if you zoom in here, you can see where the dot is moving.
Put the map back.
Put the map back
Yeah,
on.
yeah.
So you can see exactly, it goes into the vertices of this map.
Really, it matches. That's very useful.
Very helpful. Also in the bottom of the screen, you might be able to just about see that we have time remaining.
Progress bar.
Yeah, so it's very useful for being able to plan your work around what's happening. And then the most important part is we have the Raman map.
Okay.
So
Yes.
we have to select.
Click on the spectrum.
There we go. So if we take a look at this one, and
Yeah.
as you can see, we've got some
Yeah.
polystyrene peaks being visible, mainly the 1001 and the.
I will try to do it precisely 1004, let's say, yeah, and I average around this peak.
Excellent. So that's very helpful for us. As you can see, the contrast on the map has changed as we have got better polystyrene spectra as we've reached towards the center of the bead.
Okay.
And so there we go, we're able to see this is our 1602 peak, we've got our 620 peak here, our 795, 1155,
So
1450.
far looks convincing to
Yeah.
me.
Yeah, it's very convincing.
So let me try to do the simple math. So basically it's 1 micron particle, and our step size, what was it? Step size was
50.
Let's say 150 nanometers. So basically 1 micron should be 6 pixels.
Yeah.
Roughly
6 or 7, yeah.
6 or 7 pixels. Let's count 1, 2, 3, 4, 5, 6, 7. Okay, so basically it's clearly 1 micron.
Yep, and we're able to see now, as it's coming up, we're able to see the separation between the two beads that
Really?
we're analysing here. Yeah.
Yes, there are two and they are connected. And do we see it in Raman?
Yep.
Wow, we clearly see that.
Very clearly.
Mm-hmm.
So.
And this is a special feature Andrei developed, make square pixels, so you actually see the physical actual dimensions
Oh, that's very.
when you click A.
Yes. Yeah. Much. Very useful for people.
And they are so much, you know, usually 1 micron polystyrene beads, they provide noisy signal.
Yes.
But look at this. This is not really noisy. It's
No.
without any background correction, smoothing, whatever. This is raw.
Yeah. This is the raw, and in fact, you can see in our settings we're only using 1 rep count as well, so we're not even
One
averaging through
repetition,
several.
240 milliseconds, and this is a power from the spectrometer without objective and without dichroic that is inside. So maybe on a sample we have like 12 milliwatts.
Yeah, something in
I
that
think
order.
it's a very good result.
Yeah, it's a
really
very
great
good
result. Should we abort and try axial resolution?
Yeah, I think we can finish this, and I
Yeah,
think you should
I
show everyone how to do this axial resolution.
So, for that, I'm going to use tweezers and place in the sample area just a piece of silicon. You know, it will give us a very good guess. Go millimeter down, please. I close the lid. And let me try to focus back. So you enjoy it with the lateral testing. Let me enjoy with the axial testing.
Happily, yes.
Okay, so we get to the sharp image. Let me turn on the laser, and I want to see the silicon strong peak at 520. Yeah? And this is a laser dot. Here it is. Yeah.
Yep.
Okay. And I would like to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 microns down, and few more. Let's say like that. And then we go 25 micron plus. So I click here, and on the mapping settings, I deselect XY and I select Z. And position is here, so the range we agree 25 micron.
Yeah, 25 microns seems good.
And maybe 31, 35, let's say 35 steps. So the step size would be 700 nanometers. Yeah, that's good. I press start. And before I do that, maybe a few more averaging. So we
rename the.
rename, yes, rename. So this would be silicon Z test number 4, let's say, and I press start. So what's going on in the usable image? We are getting closer to the focus, so we go through the focus, and I see our Raman signal will soon start growing.
Yeah, in fact, it already has. You see it's
and that we should be able, I guess, to also observe on the live mapping.
Yes.
Like this one. So this is a silicon peak, and it's appearing and then disappearing slowly. Yeah.
Yeah.
Let's try the cross sections. Okay. I want us to measure the resolution actual. Okay. This is a very nice sharp peak of silicon and cross section. This is a spectral dimension, and this is an axial dimension. Let's get, where is the one? This is 1 micron. It's 2 micron, this is 3 micron. I would say, yeah. So this is roughly half. This is 2 microns net right now.
Yeah.
And we have like 1.2 net per half maximum. So 3 micron resolution 400x at the penetration depth of few micron in silicon. I think we are very close to diffraction limit.
Very, very close. And imagine that in this form factor, being able to carry this in a backpack, take it out directly to the field. Could even just pop the lid open, grab the device out and use it.
I think it's a great tool. Yaroslav?
I hope you enjoyed this demonstration, and if you are interested in acquiring our Lightnovo miniRaman Microscope, you're welcome to contact us through our website, email or phone. Thank you for your attention.
Thank you.
Thank you, bye.
Bye.